And now I have the honor to introduce our keynote address, Navin Sharma. Navin is Vice President of Product at Stardog, a leading enterprise knowledge graph technology platform provider. He is a highly regarded data management expert and seasoned product management executive and has helped organizations achieve significant growth with new production innovation and adoption. Among other positions, he has served as VP of Product at both Precisely, formerly SyncSort, and Pitney Bowes Incorporated. Let's give a big round of applause for our keynote speaker, Navin.
Thank you, Amelia. Again, good morning, good afternoon, good evening, depending on where you are and what time you might be watching this particular keynote. Welcome to Data Science Connect. And this particular keynote, the topic around semantic layer for the hybrid multi-cloud, more than a metrics layer. Well, let's talk about why I'm here. For me, I consider myself a data innovator. I assume for the folks that are on this call, you guys consider yourself as data innovators for your respective organizations, or at least aspire to be one. So what makes us all come together, at least in this type of a forum, to learn and really think about how we want to look at the data and how that data turns into generating insights about the world for our respective organizations. And we're here to look at ways to detect patterns in the data, the likelihoods, the causal relationships, and be able to classify things and predict others, right? So we all need as much access and as much information to make decisions and be more data informed. And to that extent, we also know that those companies that are actually data informed are actually benefiting across a lot of different operations and functions inside the enterprise. So this research study from Accenture talks about how 77% of the organizations that are using data are reimagining products and services like never before. 70% are seeing tangible and measurable value from data, including things like operational excellence or optimized customer service or creating new innovative products and services. And about 60% are using data as a business case to reduce internal reporting and operational costs. Yet, again, according to the research study that Accenture conducted of 190 executives in the last few years, only 32% are really in a position to take advantage of all of this data that is available to them inside the enterprise. So why is that? Now, what makes this problem really hard? Well, again, this is not new to a lot of folks who've been involved in the industry for a long time, right? From where I come 20 years ago, we were working with data on-prem. A lot of that data oftentimes was structured, right, in its ability for us to be able to report on things for our various functional departments. But that has really compounded with the advent of cloud, and not just the idea of one cloud environment, but multiple cloud environments, and being able to operate in a hybrid environment where we still have lots of our data and applications on-prem, and we're aggressively moving towards bringing more and more information to the cloud environments that we're setting up, right? And why is that? Of course, storage is becoming cheaper, and our ability to process lots more data is the advantage we see when we shift a lot of our data processing workloads to the cloud environment. But at the same time, that's also creating this complexity within the larger enterprise, and being able to work across a heterogeneous data environment where data is no longer just plain structured, but unstructured, semi-structured, and oftentimes not curated, or in the way it's structured, it's either relational at times, or maybe even leveraging graph technologies. And we'll talk about why this landscape is just making the harder even more compounded for organizations to make sense of this information. But what is also true that is the fact that our data management operations haven't really kept up with the times, right? So yes, there's been a lot of new technologies that have come in the last 5 years to help us operate better in the cloud environment. But when we really look at it, the next layer down, which is how do we bring this information together? How do we structure information? How do we make data accessible and available to the users and the consumers? We're still following practices from 20 plus years ago, right? Which is built on brittle ETL pipelines, which is built on being able to push as much processing, perhaps as much storage into either one cloud environment or another, where we're creating these proprietary lock-ins. Updates are still slow as they move from where the data is stored to where the data needs to be consumed. There's still no ability to self-serve because we're still relying on specialized skill sets in order to process data for the business and for the enterprise. And all this data sprawl is creating more governance issues across the organization. And at the end of the day, when we do deliver this information to the consumer, they really have no ability to contextualize data across various domains. When we take data out of its application, when we strip that data, like SAP data stripped out of SAP, you lose that context, right? And so there's no ability to contextualize that data across those domains. So what hasn't changed over the last 20 years is the data management practices that really haven't kept up with the times. And so we know that this is a problem that is only going to grow with growing volumes of data and distribution, which is making really hard for organizations to exploit their assets more efficiently and effectively. This is coming right out of Gartner's research report around leveraging semantics to drive business value from data. But at the same time, the same report calls out the need to adopt a semantic approach to their enterprise data. Otherwise, they will face an endless battle with data silos. So the key word here being adopting a semantic approach. So let's look at what that really means and why that it's important. So yes, semantic layers to the rescue. I'm sure for those that have been in the industry for a long time, especially in the data warehousing and business intelligence world, semantic layers is not a new concept or a new idea. It's been around, especially within the BI context for going back 20 years. We did try this before, and yes, it did alleviate some concern, especially in the context of BI. But if we look at how those semantic layers were built, they were still built on the relational paradigm, which was great, by the way, when we needed to do high-speed aggregates. It was great to be able to do just-in-time data warehousing to support our business intelligence initiatives. And at the end of the day, where we found it to be limiting was the fact that it was all about capturing consistent KPIs or metrics. So this notion of a metrics layer, which has slowly emerged in the recent times, with the likes of DBT, sort of leading the charge along those lines, or even what we see from MicroStrategy or Tableau. The idea of a semantic layer was still notionally a logical data warehouse in some ways, right? So this notion of creating these consistent metrics to deliver back to the business, which is great, right? It is a use case, and it certainly delivers value, but it was very limiting and is limiting in terms of what more value an organization could be getting from a semantic layer that perhaps was not necessarily limited to just metrics. And so there is a better way, right? When we look at where a lot of organizations have started to really think about leveraging data, it's all about this notion of finding and accessing data based on its business meaning. So the idea that data may get represented as strings or columns in a table is the way it needs to be structured and stored, is not the way that data should and needs to be consumed by the consuming application or the end consumer, in this case, someone in the business, right? They understand aspects like customers, suppliers, products, orders, right? That's what's important to them. That is meaningful to them. And looking at information in that manner is much better and much easier and much faster for them to be able to make decisions. And so having meaning and relationship to provide that context separated away from where the data is stored or how it's structured becomes that much more important. And that better way is really about delivering a semantic layer that is powered by a knowledge graph. Now, knowledge graphs, the idea of a knowledge graphs have been around for a long time. We just don't know it. They perhaps haven't been referenced in that manner. But in 2012, when Google evolved its search engine, in fact, Google coined the term knowledge graph when they changed their search in 2012, where when you look for information on the left-hand side of that screen, you get presented with ideas, related concepts, the genres of that time, other people, locations that might be relevant. So you get the full context of what you're looking for represented as a knowledge graph. And those knowledge graph ideas are not just limited to Google search, but it's how a lot of the largest B2C organizations are structuring and monetizing data within the context of the value they're delivering. So think of Facebook, think of LinkedIn, think of Twitter. All of that data is structured as a knowledge graph, right? So the idea of being able to link all of the related ideas and concepts that are possible. And not only that, it is now feeding the way we communicate, right? You look at your Alexas of the world or your Googles of the world, when you're asking a question, that is getting powered by a knowledge graph. And that is just that much more important as you think about this in the context of, well, how would an enterprise go about taking a similar approach in ways that allows them to be more flexible, more agile, and make more users inside the enterprise in a position to work better with data, especially when it has meaning attached to it. And look, this is not just in the context of B2C. We're seeing this across the largest of enterprise organizations that are now looking at how they use knowledge graphs as a critical enabler for their data and AI initiatives. And this is Gartner's Impact Radar for 2023, where they call out knowledge graph as becoming mainstream in the next 1 to 3 years. And those companies that are forward-looking have already started to take advantage of the idea of embedding a knowledge graph foundation within their modern data and analytics stack. And you can see that, in the context of what Gartner's saying here, which is all about companies using graphs and semantic approaches for natural language technology projects will have 75% less AI technical debt than those that do not. And this is even more relevant in the current news of large language models and ChatGPT, right? Knowledge graphs will serve as the foundation by which you train your enterprise data to work in the context of large language models to improve usability and searchability and findability of information across the enterprise. And so with a semantic layer powered by a knowledge graph, the opportunity and potential applications are truly transformational, right? So you think about it from that context. Well, what makes a transformative semantic layer? Well, a transformative semantic layer provides data models that are abstracted away from where the data is actually stored. It enables data reuse via schema reuse, right? So you can take the same schema, the same ontology, and apply it and extend it towards another use case. You also have the ability to federate access over the actual physical data. So you don't have to copy data every time you need to serve the need for the business. You can leave data in place and federate access across that heterogeneous set of sources of information. You also recognize that business logic needs to be applied in ways that serves as almost like a domain vocabulary, right? So these are inference rules. So I know that, if I am the parent of my son or I'm the father of my son, that in order for me to infer that his parent or his dad on the other side is me, or his sibling, because I have another daughter, is also referenced through that logic. Because if I have a daughter and a son, that means the logic dictates that those two individuals, i.e. my children, are siblings of each other. So that business logic allows us to infer new relationships and identify new patterns in the data. And more importantly, presents this contextual insight, this context-specific search capability where you're now looking at these connected data relationships, where relationships become first-class citizens. I know we talk about relationships in the context of relational database management systems. And I have to say, well, no surprise will come as no surprise to many of you that relationships are not first class in the context of relational database management systems. And so when relationships become first class, you essentially allow yourself to look at the broader context, this connectedness between data and across the supply chain in ways that is fast, efficient, and more complete, because you're able to search across those relationships as well. So this is not obviously, unique to, Facebook. This is not unique to Google. This is already happening, and no one is waiting for Gartner's view of the world to say, let's wait another year, because that's Gartner's view that will become mainstream in a year. Well, forward-looking enterprises, excuse me, and even the data innovators inside of us, inside these organizations, are already using the knowledge graph powered semantic layer to transform use cases within their industries. So let's take a look at some of those examples, right? It's everything from a large pharmaceutical like Boehringer Ingelheim, where they're accelerating drug discovery by enabling their researchers, their scientists to review and reuse past research, combine that with preclinical, clinical R&D information, and be able to look at ways to speed up drug discovery by finding answers more quickly. It's increasing, the bioinformatician output from scientists, where they're able to quickly answer data that link data from one domain to another without having to spend time cleaning data or creating additional localized data sets that serve their needs. And so the idea of taking data as it's represented in the underlying data lake environment and attaching meaning to it, that enables these researchers and these scientists to get up and running quickly, and recognizing the insights and the information coming back from that data through that connected meaning-based information makes it possible for them to be more data informed and drive intelligent decisions. And that's true across not just pharmaceuticals and life sciences companies, but also large financial services companies, right? So everything you can imagine, from an understanding credit risk, operational risk, to anti-money laundering, and looking across your products, across your wire transfers, across every transaction that is occurring, sort of follow the money trail. Represents data that is highly connected across organizational silos, yet being able to provide the full context, full picture, where business users, to this executive director's actual comment, business users get wide eyes, right? They see the power of the semantic layer providing transparency across that entire money supply chain. And so once you have built that semantic layer, you start to see huge benefits. And again, you start thinking about additional use cases. And like I said, again, it's credit risk, it's operational risk, it's IT asset management, it's know your customer 360 benefits. The use cases are endless. And look, this is not just limited to big banks. We see this with NASA, whose entire mission to the moon, Artemis mission to the moon, is powered by a knowledge graph foundation that takes all of system engineering data from the earliest flight modeling stages to test and validation and verification to the launch and beyond. All of that through model-based system engineering that is captured and encapsulated within the knowledge graph to enable NASA engineers to ask new questions, explore and examine the connectedness of data and its impact when it comes to changes throughout the mission. A perspective across industries where these data innovators are leading the charge within their own industries certainly makes it transformational as you consider how this applies to your own industry. With that, I'll kind of stop here and really give you guys an opportunity to answer some questions, ask some questions. Let me actually answer some questions as well. I see that there are some questions here, so give me 1 second. I'll look through this. All right, so how, according to you, the semantic approach and data support resolution social problems such as inequality, reducing social economic disparities, food and water security? Wow, it's a very loaded question. Obviously, the idea of working with data in ways that you can encapsulate every possible aspect of a transaction, a service, in ways that provides transparency is to me the biggest value here. And you think about how you're able to bring this level of knowledge to the knowledge workers within this context, I suppose, where they can look at all of those aspects of social economic disparities and bringing that visibility and not being limited by what data and what data is available where, how to best connect it, having the expertise from a data engineering perspective to stitch it all together. This gives them visibility. This gives them the ability to see how these things connect with full transparency. So to me, the aspect of transparency really plays a big part here from a semantic perspective. Question: how would the implementation of semantic layer differ in data lake versus a data mesh? Again, so I consider semantic layer to be a key element of how it fits within the context of, frankly, a data mesh. Data lake, to me, is the source of a lot of information that the semantic layer can enable. Data lake is where data gets landed, is cheap from a storage perspective, but still lacks context, still lacks the ability to have connectedness and meaning across those data relationships. And so the semantic layer really enables that. In the context of a data mesh, what we're really looking at is how do you work with data that's distributed and enable distributed governance to various teams, so you can create what are called data products. And so semantic layer, where you can abstract the data model that is important to a specific domain, can be created with its own set of inference rules and logic, with its own set of data quality constraints, with its own set of role-based access policies, and then having those separated domains that get represented as data products be able to bring that together should there be a desire to look and connect all that data across those domains. So in essence, it takes a nice hybrid approach where it can enable the idea of a data product and data as a product, and at the same time work in the context of a data fabric where your source of data still might be within a data lake, but then being able to make different teams inside the enterprise independent in their ability to craft these domain-specific data products, and then bringing it all together at the end if there is a desire to do that for the good of the larger enterprise. Another question here. Most current knowledge graph completion methods focus on extracting triplets from a closed world data source. That means generated triplets are new, but the entities or relationship in the triplet need to already exist in the knowledge graph. Not sure. There was a question here. There's a question: is the knowledge graph the same thing as a graph database? It is actually quite different. Graph database, so if you think about subcategories in graph technologies, you'll have graph databases, graph analytics, and knowledge graph. In fact, Gartner has started to create these sort of subsegments as well to make that much more clearer to the larger audience out there who are trying to understand the same thing. A graph database is essentially just that. It is a database where you bring data in, physically moving data into a graph database, whereas a knowledge graph, really an enterprise knowledge graph like a Stardog platform, you're not you don't have to bring data together inside and physically and materialize that. Data can be left at source, and the actual construction of the knowledge graph can be mapped at the metadata level. And so at query time, it transfers those queries into the optimized SQL queries for the source so that it can actually bring that data together across those sources in more of a federated approach rather than a materialized approach. More importantly, a knowledge graph also conforms to these open standards around semantic graph technology. So the idea of open standards being relevant, especially from an interoperability standpoint, becomes that much more important. And lastly, the idea of creating this abstracted data model away from sort of almost like a canonical data model away from the actual database itself is a feature of a knowledge graph platform and not so much a graph database, right? So this abstracted data model layer is an additional benefit. And the last thing I'll say is this notion of inferencing is, again, a key feature of knowledge graph where you don't have to physically, explicitly define all of your relationships, that you can infer those relationships based on either business logic or machine learning statistical inferencing to identify new relationships inside of your data landscape. So not everything has to be manifested as an explicit relationship within the data model itself. Actually, good question. Good point, Samuel. I will absolutely do that next time to mention your name. Let's see. Besides all things positive, what are some of the challenges with semantic layer? Is another layer needs integration with many other tools, a significant downside? Yes, and I know we're kind of reaching the end of our time here. I'll answer this last question from Isatu. Yes, look, semantic layer is like most things in the world, is not the answer to everything. So it is important to understand where semantic layer really provides benefit to an organization. And at least the way I've been framing the idea of a knowledge graph powered semantic layer, it is not meant to be one where you do OLAP type aggregations for the purposes of BI, right? Those are best done by those relational oriented semantic layers that run large aggregations over data. Where you're really looking at individual data elements, individual nodes within the larger data landscape, this knowledge graph powered semantic layer really plays an important role in that context. The other benefit, as you highlighted, an important aspect is to understand is not all knowledge graph platforms are created equal. So being able to have a knowledge graph platform that can seamlessly work inside of an existing modern data stack, where you may have your data lake in Databricks or your data catalog defined in Colibra, or your BI reports in Tableau. Knowledge graphs should quickly and easily fit nicely and interact and interoperate with all of those tools inside the enterprise. So that makes it an important aspect when you consider when you're considering a semantic layer, especially one that's powered by a knowledge graph platform. Now, how well does it fit within the larger context of the enterprise? Lots of great questions. I know we're out of time. Lots of great sessions ahead. So I'm hoping that you guys can join me in my session later this afternoon. We have tons of other sessions coming up from Stardog as well as other speakers. So please follow along, learn, share. And look forward to continuing these conversations with this group. Thank you very much.